by mitosis. So one cell turns into two, two into four, four into eight, and again, they're all identical. And they grow and reproduce by mitosis, and they're all identical. Okay, this growth is controlled by testosterone. Okay, letter A. Primary spermatocytes are still diploid. Primary spermatocytes are still diploid. Okay, then B. The primary spermatocytes will split into forming two secondary spermatocytes. This is under B. The primary spermatocytes then split in two, forming two secondary spermatocytes. This is called meiosis I. The primary spermatocytes split in two, forming two secondary spermatocytes, and this is called meiosis I. Okay, number 4. The secondary spermatocytes, letter A, are haploid. Haploid is abbreviated little n, and it basically means half the chromosome number. So we've gone from 46 to 23. So now the secondary spermatocytes have 23 chromosomes. Okay, then B, then the secondary spermatocytes undergo meiosis II, forming 4 spermatids. Then the secondary spermatocytes undergo meiosis II, forming 4 spermatids. Okay, number 5. The spermatids are haploid, and then they grow and develop into mature sperm cells. The spermatids are haploid, they grow and develop into mature sperm cells. And then 6, the mature sperm cells are still haploid, and they are capable of fertilizing the egg. And they're capable of fertilizing the egg. Okay, so let's take a look at the picture. Okay, this is the original cell. There's the spermatogonia cell. Okay, it's 2N, has 46 chromosomes, just like all the other cells in our body. It undergoes mitosis and produces identical cells. Okay, so they're undifferentiated, they all look the same. They're diploid, just like the original cell, okay, and they have full chromosome number, which is 46. Then, during the end of this stage, meiosis during the end of this stage or whatever, these cells grow larger. Now, they should have made this one bigger and they didn't, but this should be bigger than this. And then this cell which develops is the primary spermatocyte. It still has half the still has the full chromosome number, it's still 2N or diploid, but then at the end of this phase, this is when meiosis 1 will begin. Meiosis 1 is going to split the cell in half, so where we had one cell, now we have two, and now they are haploid with half the chromosome number. So we went from 46 to 23. These cells are called secondary spermatocytes. Okay? All right, these cells undergo meiosis 2 again, or they split again, and now each cell produces 2, so we've got 4. They keep their haploid status, and these are the spermatids. Then these grow and develop, and then we finally land up with mature sperm cells along the way that look like this. They retain their haploid position, and now they are capable of fertilizing the egg. So for every one spermatogonia cell that we began with in the beginning, which is up here, the male makes 4 sperm cells in the end. Okay, so for every one, he makes 4. We're going to see that's a difference between males and females. Okay? All right. Okay, I'm going to stop here because we need a little more time. So tomorrow in lab, we will continue on with the second dissection. Okay, that's the most difficult of the 3. Okay, once we get through that, then we'll be able to do it. Okay, Misha?